It is proven that the celebration of birthdays is healthy. Statistics show that those people who celebrate the most birthdays become the oldest. And welcome to statistics. So, we're going to be talking about sample statistics and population parameters and categorical and quantitative variables. We're going to be introducing you to some of the basic vocabulary. So, first of all, what is statistics? At its most basic, statistics is the science of using data to make decisions. Statisticians decide what data they need to answer a certain question. They determine how to collect that data, and then they design experiments if necessary, collect data, interpret and analyze the data, and then report conclusions. And unlike most professions, statistics can be applied to a vast number of fields or issues. So odds are you will be encountering statistics. Here are just four fields: the environment, public safety, healthcare, and sports.
So in high school, I had never even heard of statistics. And I knew I liked math, and I knew I liked science.
In high school, I went to a conservatory for music. I was a viola performance major.
When I started college, I was taking a bunch of math and economics classes. And then in my junior year, I took a probability and statistics class.
I remember sitting there in the classroom thinking, wow, this is a really interesting problem, and he's using statistics and probability theory to try to solve it.
Statistics is amazing because it has many diverse applications, from search results on Google or Bing to recommendations on what you should be shopping for on Amazon.
If you're watching a YouTube video and at the end you get recommendations for other videos, statistics were used to give you those recommendations.
I've seen statistics in ice skating. I've seen statistics in agriculture. I've seen statistics in climate control. Statistics can actually be anything that you like, anything that you enjoy, anything that you want to do, anything that you're passionate about. You can, take statistics and it fits.
I'm very lucky to get to use statistics to answer some of the questions that I think are the most important questions about social justice and human rights violations. And on my best days, I get to spend the majority of my day doing data analysis to answer questions for the United Nations, to contribute evidence to war crimes trials.
As a part of my PhD, I created a statistical software package, and Google emails me every time someone uses it. And people have used it to analyze DNA and find genes that are related to cancer.
It's even used in the food pyramid. You know what I mean? When we come up with suggestions, of what you should eat and how much of it you should eat, we try those things using statistics.
Statistics is critical for everybody entering the workforce because so much of industry and government and everything today is data-driven.
Just like it's important that we all know how to read, we all need to know statistics.
Look around you. Everywhere you are, there's data, there's information.
Whatever your passions are, statistics will be involved.
We're producing so much data these days. Regardless of the field that you pursue, whether it is astronomy, criminal justice, or medicine, going forward, you've got to know statistics.
Now, there are great job prospects in statistics. In fact, it is considered the number one, it's number one on the best jobs in business in 2016, and it's number 4 on the best jobs in 2017. Now, according to the Bureau of Labor Statistics, BLS, the average growth for all jobs is predicted to be 7%, but growth for statisticians is projected at 34%. So now you know why statistics might be a good choice to study for you. Now that we've done that, let's go ahead and go over some of the basic terms. So let's talk first about population and sample. And I'm going to come up with maybe something I'm trying to find out. Let's say I'm trying to find the average weight of Americans. Well, the population would be the population of the U.S., and by Americans, I mean U.S. And a sample would be the people that I picked to measure, because I can't go through and measure everybody in the population. Well, I could, but I don't have enough time or money to do that. So the sample would be the people I picked to be representative of the population. So a population includes every individual of interest. A sample includes only some of them. Some examples of populations, you could say students at Cedar Ridge or seniors at Cedar Ridge. Some of you are interested in people majoring in geography. A lot of you are going into nursing, so you might say, oh, nursing students, I might want to know more about them. So that would be your population. But the sample would be the people you actually select or individuals you actually select to represent them. So now what's an individual and a variable? So sometimes people mix up the two, and the individual is the one that you record the data about. So let's say you were surveying nursing students, all right? And you could ask them, you'd be asking them questions, and the questions you ask them and the answers they give you, that would be your data, all right? For example, you could ask them, did you take statistics before you went to college? And their answer would be yes or no, all right? You could ask them, what was your GPA before you went to college for nursing school? And that answer would be some number. So a categorical variable cannot be answered with a numerical value. For example, when I asked about took statistics, that would be my variable. And the yes or no, since that's not a number answer, that's a categorical variable. A quantitative variable, like if I ask them their GPA, they're giving me a number. So that's always numeric. So quantitative variables can also be discrete or continuous. A discrete variable can only take a fixed set of possible numerical values within a given range. So I could ask them, how many math classes did you have to take in college? So they're not going to say 1.5. They might say, oh, I had to take 2 or I had to take 1, and that would be discrete. A continuous variable can take any possible value. So for GPAs, you know, they can go down pretty fine. We tend to round them off to the hundreds or thousands. I think for top 10, it can get really close. And so that's a continuous variable because it can be almost any value in the GPA. So up to a certain max and above a certain min. So which of the following are discrete and which are continuous? So the numbers of miles hiked in a day, that can take on pretty much any value. So you could have hiked exactly 12 miles in one day, or you could have hiked 12.2 miles, or 12.2345 miles. So that one is definitely continuous. If we had a ballot and we're voting yes, say on school bonds, you're not going to have half a vote that's yes. It's either one vote is yes or it's no. So that is discrete. You can't have fractional votes. Number of heads from coin flips is similar. You can't get half a head. So that's discrete. An amount of time you have to wait at a light, that can take any amount of time. It's not like, oh, if it's over a minute, now you got to wait till 2. It could be 1.5, 1.2, any value of minutes. Although sometimes I'm sure instead of continuous, it feels eternal. So the distribution of a variable, and we'll get into that in the next lesson, describes what values the variable takes and the frequency it takes them. So in our next lesson, we'll actually be looking, well, the lesson after, we'll be looking at how to display data and show data distributions. You're planning to purchase food for your club's concession stand during a football game and would like to know what type of food to buy and how much. What is your population of interest? Well, you might be tempted to say, well, it's high school students. It's a high school football game. But not all high school students attend football games. And not only that, when you go to the concession stands frequently, it's not them who are buying. Now, some high school students do have the money to go spend at the concession stand, but a lot of times it's the parents that are buying food. So in this case, I would actually consider high school student families and friends who attend football games. That would be your population. Now, let's say you want to get some more information so you can prepare your concession stand, all right? What kind of data might you want to collect? Well, maybe you want to know the percent of the population who makes purchases. So that's the statistic that we're going to get from once we get all our data together. Now, you're not going to go up to an individual and say, what percent of you is going to buy concessions? What you're going to do is say, do you usually purchase food at football games? So I'm going to count these people who say yes and then figure out what percent they are to get my statistic. So this is a categorical variable that I'm recording because it's actually not a numeral, it's a category, yes or no. I could be looking at most popular food, in which case I would say, what food do you normally purchase? Again, a categorical variable. If I want to know the average sale per person, I could say, well, how much do you normally spend at the concessions? And that would be a quantitative variable. Let's look at another example. You are contacting state governments around the U.S. to compile data to compare the different states. What are the individuals in your study? Well, you might be tempted to say, oh, it's everybody, we'll say Texas, everybody in the state of Texas. No, those aren't the individuals. We're not going to contact every single Texan to get information about Texas. What we'll probably do is contact the state government or some individual representing the state. So each state is an individual, all right? What is the population? Well, it's all those individuals put together. All of the states in the U.S. are the population. Now, here are some variables that we could be collecting for each state, and let's determine if they're quantitative or categorical, and if it's not a variable, explain why. So the size of the state, Texas definitely has a size, and that would be a number. Population of the state, same thing, it's another number. Major industries, that would be categorical, so we'd probably even have some lists. State flower, bluebonnet, and that's categorical. State bird, categorical. Total interstate miles is quantitative. Unemployment rate, that's a number. Average age of a person in the state, also a number. Percent of people who are school age, that's quantitative. Average household size, that income, and then also size, those are both numbers. Now, if I go to Texas and I say, what's the number of states surveyed? Texas can't answer that. Texas can only answer about Texas. So this is actually not a variable because it involves more than one individual. Now, one last note on your notes, is it possible for a statistic to be a variable? Well, it depends on what you're measuring. So if I said average household income, that is a statistic for the state of Texas, and I can record that as a variable for the Texas as an individual. A little bit confusing, but you'll get used to it. So depending on who the individual is will determine if you're recording a variable. And then you take those variables and you use them to create statistics. So can a statistic be a variable at the same time, and why or why not? Yes, well, and it's very meta. A variable is the label for the data you're recording. Now, you can record a single measurement. For example, if I wanted to test my blood sugar right now, I could find my measurement for blood sugar, right? Or my blood pressure. But that's one measurement. Okay, it's not a statistic. But when I call my doctor and I say, hey, I don't think I need these blood pressure meds, and I don't, by the way, he says, well, what is your average blood pressure? Well, that would be the statistic for all the measurements I've done on my blood pressure. Now, we could go meta, and this is how a statistic becomes a variable. Let's say we were looking at a new blood pressure medication, right? And you wanted to see how people were responding to it, if it was helping them with their blood pressure. Well, you wouldn't use just one reading for each of your individuals. You would use the average of their readings, most likely. So you would be using their personal statistic to come up with a more meta statistic. Here, for example, average household size is a variable because it's what we're recording for the states in this example, but it's also a statistic for each state based on their own recording. So when I'm in Texas and I want to know average household size, I'm recording individual household sizes, right? Then I average them and I say, the average household size in Texas is this. But if I'm going to each state then, and I'm someone at the Capitol, asking them, how big, what is the average household size in your state? When I ask them for the average, I'm already asking for a statistic, and I'm recording my variable is then average household size in the states. And as a quick recap here, if you look at it, here is population. So I have them pretty much in the same order as the foldable. And basically, population is a parameter. So you see, these are actually all measurements, right? The individual measurement here is for a variable. So that goes with individual. This is a measurement for everyone, averaging or taking the median or some number calculation, and that's the population parameter. See how it goes with population. And finally, these last two go together. The sample goes with the sample statistic.